Chapter 1, Section 2 in your book is all about how to measure matter. Now, you are familiar with matter at this point. You understand that matter is anything that takes up space. It's the stuff that the universe is made out of. And you know that matter comes in a variety of shapes and sizes with special properties called characteristic properties that govern how it behaves and how it interacts with other pieces of matter. Today's lesson is all about how to measure the physical substances that make up the universe, how to measure that matter we were talking about in Section 1. The two objectives for this section are to explain the difference between weight and mass. Oftentimes people think that those can be interchanged, but they can't. And then the second objective is to calculate the density of a substance using SI units for mass and volume. So we'll learn a little bit about what SI units are in this lesson as well. So mass and weight. We'll start with weight. Weight is the number that you see if you go into the bathroom and weigh yourself on a scale. Weight is a measurement of the force of gravity exerted on an object. In other words, weight is the amount of force that the earth is pulling you down with. So everybody is made up of a different amount of matter. We all have a different amount of bone mass, we have a different amount of muscle mass, we have a different amount of fat mass, and when you add all those parts and pieces up, we all have an amount of matter that's unique to us. Because we all are made up of a different amount of matter, the Earth's gravity is going to pull us all down towards that center core at a different rate. So weight is a measure of how much force gravity is exerting on you or on any other object in the universe for that matter. So if you were to take a tennis ball and hold it up and let go, you would notice that it falls toward the center of the earth because gravity is being exerted on it as well. When it comes to gravity, we know that there are a lot of really big, really massive objects in the universe. The sun, for instance, at the center of our solar system, has way more mass to it. It has way more stuff that makes it up than our planet does. And yet, when we drop that tennis ball, it doesn't fly off toward the sun, it drops towards the center of the earth. That's because the force of gravity is going to be exerted on the object that has both the most mass and is the closest to us at any given time. So because we are far closer to the earth than we are to the sun, that tennis ball, when we drop it, is going to fall toward the center of the earth. Now, if we zoom way out on this picture, and instead of looking at us and the tennis ball in our living rooms, if we start to think about the earth in the context of our solar system, now we're dealing with all really big objects, right? All of the planets, the asteroids, the moons, they're huge. And so when we get out, zoom out to that focus, now the biggest, closest object holding all those things together is the sun. And that's why we see planets orbiting around the sun. Moons orbit around planets because those are the largest or most massive close objects to those moons. So gravity is sort of an interesting thing. It's exerted by the object, or on every object, by the object that is both the most massive and the closest to wherever those pieces are. And so because of this, your gravitational force is going to be different in all these locations. Your weight is going to be different as well. You would not weigh the same on your bathroom scale if you took you and your scale to the moon as you do here on planet Earth. Mass, by contrast, is a measure of how much matter actually is contained in an object. So while your weight would change if you were on the moon compared to in your living room, your mass would not. Your mass is going to stay the same. The amount of matter that makes up you and your muscles and your bones and your brain and everything else is not going to change just because you go on a space adventure. And so the biggest difference I want you to understand between mass and weight is that weight will change depending on where in the universe you are, but mass will stay the same. You'll notice there's a video on this slide. I will attach the link to this video in the lesson later on. When we're measuring units of mass, remember mass is the amount of matter that makes up an object, we use a specialized system called the International System of Units. It's abbreviated SI units because in French, International System of Units is going to be spoken as Système International, and that's where the SI comes from in that order. The SI unit for mass is the kilogram. Now, you and I know that we're not going to measure everything in the lab in kilograms. Oftentimes, if we have our scales out, we're actually measuring in grams. The beautiful thing about the International System of Units, otherwise sometimes known as the metric system, is that everything operates on what's called base 10. That means that we can move a decimal point and we can go from a mass in kilograms, which is really pretty large, to a mass in grams, which is fairly small. Moving on from mass and weight, we have volume. Volume is the amount of space that a piece of matter is going to fill up or occupy. Solids, liquids, and gases all have volume. It's really easy for us to sometimes think about solids and liquids as having volume because we can see how much space they take up in a cup or on a shelf. But gases have volume as well. That's the reason that a balloon will start to expand as air is pumped into it. The volume of a solid is going to be expressed in a cubic unit. The word cubic means having 3 dimensions. So if you think about a block, like the block you see on the screen, it has 3 dimensions to it. We say it has length, it has width, and it has height. For this reason, when we are measuring solids, we are oftentimes going to put the label cubic meter or cubic centimeter on those volume measurements. And again, that is because those volumes are being measured in 3 directions: length and width and height. Now let's say that we have an object, a solid, that isn't square, that isn't going to be easy to measure in terms of length and width and height. Can we still calculate its volume? The answer is yes. To measure the shape of or the volume of an irregularly shaped object, you're going to use a technique called water displacement. And again, there's a video on the screen. I will make sure to include the link to that on my website. But the gist of it is you fill a beaker to a certain volume of water. In the case of the video on the screen, you see 75 milliliters of water. Then you place your irregularly shaped solid into that glass beaker that's got water in it. And you'll notice that that object you've placed in the water continues to take up space. And so what it does is it pushes water out of the way. It makes the water level in the beaker go up. And then you can calculate the difference, the amount that the water went up minus where that water started, to figure out the volume of this object that you've placed inside. Now, because we're dealing with a solid, we want to continue to use that solid volume label, which was cubic centimeters. It's really pretty easy to transfer a label for a liquid, a volume of a liquid, to a label for a volume of a solid, because 1 milliliter, for thinking volume of a liquid, is equal to 1 cubic centimeter, which is a volume label for a solid. When we're measuring the volume of a liquid in a cylinder, it's important to use your eyes to look for the meniscus. So a meniscus is a curve. The reason it exists is because surface tension. The water clings to the sides of the beaker that is in the graduated cylinder, and it forms a bit of a dip. When you're measuring the volume of a liquid, you always want to measure from what's called the bottom of the meniscus. You want to measure from the lowest point that you see inside of your measuring tool. The last type of measurement we want to talk about today is density, and density is a measure of how much mass is contained in a given volume. So this is the reason why a basketball feels way less heavy, feels like it has way less weight than a bowling ball. It has to do with the amount of matter that's packed inside that roughly approximately equivalent amount of space. Density is going to be calculated using the formula mass divided by volume. And because we're taking 2 different measurements on their own and combining them together, we can have all sorts of different labels for density when all is said and done. So remember that mass is the amount of stuff that makes up an object, and we measure mass in kilograms or grams or milligrams, depending on where we want to go with that prefix. But kilograms or grams are the base. And then volume can be measured in milliliters or in cubic centimeters, depending on if we're dealing with a solid or a liquid. So our density label could be gram per milliliter. It could be gram per cubic centimeter, just depending on what it is that we're trying to measure the density of. There is no new homework for today. Instead, I'm going to give you the rest of your morning and early afternoon to finish up your section 1.2 notes. Remember that those are due to the Dropbox on my website at 2 p.m. today. You can choose to do those notes in your notebook and then take pictures and upload the pictures to the Dropbox, or if you would prefer, you can switch to doing your notes in a Google Doc, and then you'll upload your Google Doc to the Dropbox when you're ready to turn in. Remember, those are due at 2 p.m. Let me know if you have any questions. I'll talk to you later.